Greetings and welcome to the graphics class. Question number 12, development of surfaces. The question is, development of a cone is a semicircle with radius 70 mm. A circle of maximum diameter is inscribed on the development and then it is rolled back to the cone. Draw the front and top views of that cone showing the circle. The question is related to the development of a cone, but the dimensions of the cone is not at all given. Here, the development is a semicircle with radius 70 mm. That means you are having a semicircle with a radius 70 mm, inside which there is a circle inscribed inside the semicircle. So now I am going to draw the semicircle first, then I am going to inscribe the circle inside the semicircle. After that, we will try to find out the cone and draw the front and top views. That is the procedure which we are going to do. So I am going to start with the development of the cone as a semicircle. So the dimension of the semicircle is given as the radius is 70. So let this be O and this be 70 mm. If this is the point O, then you can have the same radius in the opposite direction also, since it is a semicircle. Now you can have the curved portion of the semicircle. There is a circle inscribed inside the semicircle. That is the next part. There is a circle inscribed inside the semicircle with the maximum diameter possible. So the maximum diameter possible may be the radius of the semicircle. So you can have a circle which is inscribed within the semicircle. Within the semicircle. As usual, we can divide this semicircle into 8 equal parts. Normally we are doing that because we have to get the points from the development to the front and top views. Now we can divide this semicircle into 8 equal parts. First I am going to divide it into, say, 4 equal parts. Now again dividing it into 2. So I will get 4 divisions in one half and the remaining 4 divisions in the next half. Now I can mark the points, that is A, B, C, D, E, F, G, H, and finally I will get A again. This is the development. I have divided the development also into 8 equal parts. As usual, the outermost portion can be drawn with red color, since that is the only visible portion of the development. I think now it is clear to you. But how to draw the cone again? Normally, we are finding the development by the relation, that is the subtended angle we are finding, that is theta is equal to 360 into r by true length. That is, if you are having a top view and a front view of the cone like this, this is the radius r and this is the true length TL. So this r by TL you are getting. Now what should be this length, that is O to A? O to A is exactly true length. O to A is exactly true length. Now this is given as 70 mm in this problem. This true length is equal to 70, which is already given in this problem. So it is very simple to find out this, because theta is 180. 180 is equal to 360 into r by 70. That is, this should be 1 by 2, then only you will get 180. So r will be exactly 35 mm. R will be exactly 35. So you should have a cone of base diameter 35 mm. We will try to draw that cone next, then we will draw the front view. So initially we will draw the top view. The top view should have the radius as 35. Radius as 35. As usual, you can divide this circle into 8 equal parts. 8 equal parts. So you will get, this is O1, A, B, C, D, E, F, G and H. You can project it. From A you are projecting, from E also you are projecting. We don't know the height of the cone. So I am simply drawing this as the height. I don't know the dimension, so simply I am drawing an axis. But I am aware of the length TL. TL is equal to 70. TL is equal to 70. So I can take this as A dash and this as E dash. Taking E dash as center and 70 mm as radius, I can draw an arc. So that will mean here, let it be O into O. Now the other side also we will get. Now the cone is ready. The cone is ready. The height is already here. It is immaterial. The most important thing is the true length. The true length is equal to 70, which is given already based on the question. Okay. Now we can project these points to the front view. So you are getting this as H dash comma B dash. Here you are having G dash comma C dash, and here you are having F dash comma D dash. You can project all these things. Now you are having all the generators. The next step is to transfer these distances to this particular front view. Then only you will get the circle, how the circle you will get on this front view. That is important. So in order to get that, we can mark the points. Let this be 1. The intersecting points of the circle and the generators. The first, along OB you are getting 1. Along OC, in order to get it, to avoid confusions, say normally we are expecting along OA 1. So we can omit O1, number 1. Now along OB you will have 2, C 3, D 4, along E you will have 5. 5 and E will be the same, and along F you will have 6, 7 and 8. So the numbers are starting from 2 to 8. We are avoiding point number 1. Or you can have 1 as O itself. Without having any confusion, you can take 1 as point O itself. So I am marking 1 as point O, 1 dash, 1 dash. Now what should be the length of 2 dash? I can measure O to 2 as the radius, and that distance I can mark along O to A dash, because that only gives you true length, either O to A dash or O to E dash. Then I have to transfer as a horizontal line. I have to draw a projector to O dash B dash. So that will be point 2 dash. Now I will get O3. That also I have to mark along O dash A dash. I will get 3 dash here. I have to project this, and I will get this as 3 dash. O4 I can measure. That point also I have to mark along O dash A dash. The similar situation we have done and in an earlier problem also. The same manner you can draw that. We will have 4 dash. Now 5 dash exactly on E dash. So you are having 5 dash. Now it is very simple. If you look at here, O to 4 is equal to O to 6. When you are using actual dimensions, it is exactly like that. So 4 dash will be along here and 6 dash will be on the same point. Now 7 will be exactly along the point 3 dash itself, and 8 will be along 2 dash. Because of mirror image or symmetry, you can have the same points as, say, there is a combination of points as 2, 8, 3, 7, 4, 6, starting from 1 and ending at 5. Now we can have a smooth curve connecting all these points, say 1 dash, 2 dash, 3 dash, 4 dash and 5 dash. A similar curve you will get at the back side. That is, this may be, say, along AH, OA, OH, OG, OF, OE. That means it is say 5 dash, 6 dash, 7 dash, 8 dash and 1 dash. Now at the rear side there will be 1 dash, 2 dash, 3 dash, 4 dash and 5 dash. That is also shown as visible because of the coincidence of, as mentioned. Now we have the front view. The next step is to draw the top view. We have to transfer all these points starting from 1 dash to 8 dash to the top view. We will try to do that. So from 1 dash is along O dash. So we will get 1 along O1. So this is 1. Point 2 is along O dash B dash. So from 2 dash I am drawing a projector which will come here. So this is 2.2. Now 3 will be along O dash C dash. As we know, whenever we are getting a point like this, we will transfer it either to O dash E dash or to O dash E dash, whichever you prefer you can do. Now I have transferred this to here. So now I can project it towards O dash A dash. I can rotate this. Whatever point I am getting here, I am taking O as center and rotating this towards here. Using an arc, I am rotating this. So this will be point 3. After that, you will get point 4. Point 4 will be point 4 and 6 is this one. So from 4 you are drawing a projector that is along OD. So that is 4. 5 is exactly on E. So you can have a projector from there. So you are getting 5 here. Now 6. After 4 you can extend that, you will get along OF, this is 0.6. Now again 0.7, that also you can rotate because 3 and 7 are at the same level. We can transfer this point or project it towards O dash E dash. You are projecting it to OA, then you can have another arc which is going towards here. So this is 0.7. Now the remaining point is 0.8. Now we have to get 0.8 also. In the same manner, we got 2, we can extend this and we will get 0.8 here. So we are having now starting from 1, 2, 3, 4, 5, etc. up to 8. 8 points are there. Now we can have a closed contour connecting all these points. I am going to draw this with another pen, that is black color. Starting from 1, 2, 3, 0.3, 4, 5, 6, 7, 8 and returns to 1. It is 1, 2, 3, 4, 5 to 6. Now I am going to conclude. We have started with the development of the cone. In the question it was given that the development is a semicircle with 70 mm radius. We have drawn the semicircle with 70 mm radius. In the question it was given that there is a circle inscribed inside the semicircle with the maximum diameter. Using that we have drawn the circle. Then we have divided the semicircle into 8 equal parts in order to catch the points properly to the front and top views. Then we have drawn the top view and front view by making this calculation, that is the subtended angle theta is equal to 360 into r by true length. From this we got r is equal to 35. Using that we have drawn the top view initially, then we have drawn the front view. Then we have transferred all these points, say 1, 2, etc. up to 8 to the front view as well as on the top view. In the front view you got a curve like this, in the top view you got a cardioid. So we have completed this particular problem. Now we can practice this. Thank you.